Um, Thank you very much for coming to my talk about Hackney City. A little bit before we start, some stuff about myself. So my name is Amichai Neiderman. I'm a security researcher from Israel. I work for a company called Equus Technologies, and I mostly do vulnerability research at work, and it's fun for at home. And a little bit about what you're going to have today. It's going to be a walkthrough. This talk is going to be a walkthrough. I'm going to take you through the steps that I took during this research that I did. And the best way to do it is just actually, let's start. So there I was driving my car one day, and I saw this icon on the middle of the road. And for those who don't know, this means there is an open public Wi-Fi somewhere around me. I saw it on my phone. And I thought it's a bit strange because, like I said, I was driving my car and I saw this in the middle of the road, and it was pretty far from all the buildings. There weren't any building, like apartment buildings next to me. And I thought, well, maybe it's one of those buses with Wi-Fi on them, but nope, I was the only car there. So I was stopping at a red light, and I checked the Wi-Fi name, the network name, and it was called Free TLV. And TLV stands for Tel Aviv, which is the city that I live in Israel. And actually, earlier this year, my city, Tel Aviv, started installing Wi-Fi hotspots around the city, and they call the online municipal services. And I'm living somewhere, used to live somewhere around next to this red arrow, so I probably picked up one of those hotspots when I was driving. And I connected to the network. I had some spare time. It was a long red light. And I have this really bad habit of mine. Whenever I connect to a public Wi-Fi, I usually go to whatismyp.com and check the external IP address, the one that I get. And this is an actual screenshot from that same day. And the reason I do it is like there's this, for example, there's this cinemaplex in Israel called Yes Planet. It's a pretty big cinemaplex. And if you connect to the Wi-Fi network and you're trying to browse to their router configuration page, then they blocked it. But if you go to whatismyp.com, get the external IP address, disconnect from the Wi-Fi network, and connect to the same address, same IP address that you get using your data connection, then they didn't block it from the outside. And the username is admin. The password is yesplanet with a couple of Y, capital P, for the Israeli people here. So it's a good thing to do. You can find out a lot of interesting stuff. So I got the IP address, grabbed this screenshot, and got back home. And when I got home, I did the only reasonable thing that you could do, and I started port scanning it. And I found out that port 443 is open. That means there is an HTTPS connection. I'm still not sure what I'm looking at. It's just an opaque IP address, but it responded to something. And I tried to browse to this address, and I got this page. It said something about captivity. Didn't really care. Just click on proceed anyway, and got this page. Now, does anyone ever seen or heard about this company, Peplink? One, two. All right, that's the most I've ever seen. Well, I never heard of them before. Never. Sorry. Yeah. Never heard of them before. Never seen that logo before. And I had some free time, so I said, well, I'm gonna mess around with it. So I tried admin, didn't work. Tried root, didn't work. Tried all kind of other weird stuff, still didn't work. Tried SQL injection, and it wasn't 2006, so I was pretty sure it won't work, and it didn't work. But like I said, I had a lot of spare time that day, and I really wanted to mess around with it. So what exactly is this thing? Because I know it's a network device of some kind, maybe. I know that there is a web server, but I still don't know what it does. I looked at the HTML source code, and it revealed nothing to me. I tried to look at the headers. Maybe the web server will send some data about it. Still nothing. Didn't say anything about what kind of device it was. I tried running Nmap with OS fingerprinting, and it just returned it's a generic Linux. So I moved on, and I went to the manufacturer site. And the first thing I saw when I got to their site was Unbreakable Vpn. And I like to break stuff. And now I'm really interested in this product. So I made this like simple plan in my head, something I could explain to my wife. Well, I told her, well, I'm gonna download the firmware for this device. I'm gonna start reversing it. I'm gonna find a vulnerability, and then I'm gonna exploit it. The question is, what firmware should I download? Because when you go to the manufacturer site, you find out that this company makes everything. They make defense communications, rock solid connectivity for, I don't know, tanks, maybe, mission critical VPN for emergency communication, basically everything. And if you want to download the firmwares, all of them, it's not practical because they have about 5,000 of those, and you can actually go and reverse each and every one of them. So I need to find a way to determine what kind of network device it was. And I looked at the HTTP headers again, and I found out that one of the HTTP headers was something called the HTTP last modified header. When you send an HTTP request to the index CGI, the same page that you get when you're trying to browse on port 443, then it sends the last modified header, and it says it was last modified during May 2013. Now, usually, not well, most of the times, CGI files are pre-compiled files, so I figure out, well, maybe the last modified date was the day they compiled it. And I went over all the firmwares that they made, and it was consistent with a version 5 of for the firmware of the load balancer series, because it was, well, they released it on May 2013, and that's the product. This is how it looks like. And I started downloading all the firmwares from that same date, and I started from the top with the balance 380. That's supposed to be like their high-end load balancer. It was just a zip file containing a binary file with some strings in it, nothing very interesting. And now I changed my plan a little bit. I added another step. I have to unpack it. Now, the best way to unpack firmwares like that is just running beanwalk. It's a pretty cool tool for those of you who don't know. Basically what it does is just analyze binary files and extract firmware images out of it. And this is actually what I knew about beanwalk at that time. It was like a mystery box. You put a binary in one end and you get a file system in the other end that you can start working with. It uses all kind of heuristics, looking for magic numbers in the firmware. It does all kinds of stuff. And if somebody will ask for a tutorial how to use beanwalk, well, at that time, this is basically what I could give them. And I just ran beanwalk with -e, that means auto extract. And all I got was a bunch of useless zip files, which is kind of a fail because I expected something more like a file system, some binary files I could start working with. And I didn't really want to know why it failed. So I just moved on to another firmware for the balance 210, 310 series. It came in the same file, ran beanwalk -e, and got a squashfs file system. Now we're moving on, actually. And squashfs is just a compressed file system. It's a read-only file system. It's mostly used in like CDs, routers, places that you don't have a lot of free space, and you know that the firmware doesn't change a lot or doesn't change at all. So you can see in a lot of IoT devices nowadays. And the best way to read squashfs file system is using a tool called unsquashfs. So I ran unsquashfs and got, according to the superblock, that it was a squashfs 2.1, which is pretty old but also pretty common in a lot of devices you can see on the internet. The creation time was the end of April 2013, so I was pretty sure it's probably not the right version that I'm working on, but at least I have a firmware to work on, so it's something. And it says that data is compressed, but when it's trying to decompress it, it gets read on file system because end of file. Like, what the fuck? What does it even mean? And I tried to find out what went wrong. So the superblock seems legit. You get a right version. You get the creation time seems legit also. It came out around the same time that they actually made the firmware, the day that they released it. We can argue about the compression. Now, there's this ancient tale that goes around the internet that somebody compiled squashfs with LZMA, and when I looked at my squashfs, unsquashfs, that came with my Cal distribution, it comes with gzip, LZO, and xset, and no LZMA support. So I set out a task to find LZM, like unsquashfs with LZMA, and I downloaded FMK, the firmware mod kit. It's basically a collection of scripts that helps you to extract and rebuild firmwares. And they had unsquashfs with LZMA. And at this point, I was like ecstatic. I thought, well, this is going to solve everything. Just going to compile it, run it, going to open the firmware. It can actually start working right now. I spent some time before on it, so I compiled it, ran it, and got a seg fault. That sucks. So I started looking at the code. I thought, well, I'm going to do two things today. I'm going to open the firmware, and I'm going to help this open source project fix some couple of bugs. It's going to be like a good day. And I started looking at the code, and they have tons of bugs. But I came to a conclusion that my binary wasn't compressed with LZMA, and then said, screw it, I'm not going to help anybody, it doesn't help me, and I didn't patch anything. And then it was time to find out what's in the box. Like, what does binwalk do? Because when binwalk run, it prints so much data to the input, to the console, and I never looked at it. It usually just works. You run binwalk -e, and it usually 99% of the times it works. So I started looking at what it prints, and then looked at the first line. And the first line says that there is an X2 file system on offset 180 bytes from the start of the binary. And I don't know, for some weird reason, it didn't get it at all. So all I did just ran this bash command line and dumped everything from offset 180 of the file and mounted it. And I actually got a working file system, an X2 file system, and inside of it there was a squashfs binary. And I tried running unsquashfs on it, and it worked. And actually inside that squashfs file, the root disk SFS, there were all the important files that I wanted to research. I found all the CGI files, all kind of binaries that they're using when they're running the load balancer. And that's actually what I wanted. Now, I moved on with my plan, and now it's time to find the right version, because I know I'm not working on the right version. Or I'm pretty sure it's not the right version, but I need to find out how far away from the right version I am. So I went to the mounted point and went to the CGI directory and found a list of all the CGIs that are installed on this firmware, and took the strings out of it and ran it and wrote this Python script that just goes over to my target and send HTTP request. My target is the load balancer on the network, and iterates over each of those CGI files and send HTTP request and logs the response, the HTTP code that you get. And I saw that one of the CGI files was missing on my target. I mean, I managed to open a firmware on my computer, but it has an extra CGI file on it. So I know I'm not working on the right version. So at this point I thought, well, maybe it's the 380 that my city is using, because that's the high-end version, and maybe they're using the high-end version. I like to believe that they bought the most expensive one for my care. And so I did the same thing, ran it, mounted it to my computer, and I got the same file system. But here I didn't find any squashfs binary. I found two files called bootdata1 and bootdata2. You can see them here. And I found another file called menu.dfl, which is just a bootloader configuration. And it says that bootdata1 is the kernel, and bootdata2 is the initrd, which is basically just the RAM disk, and probably all the important files should be there, because it's basically do the same thing as the squashfs. It doesn't change at all, and it's loaded into RAM, because that's all you need during the execution of the program. So I tried unpacking the initrd, and I ran unpack initrd script that I got from the kernel git, and tried to unpack it, and it failed. I tried looking at the strings, gave me none. So weird. I tried looking in the headers, and I couldn't see any like reasonable headers inside of it. That's what's pretty weird. But does it look like random? Yeah. And if you look at the entropy graph from you can get from Beanwalk, then it says it's either encrypted or compressed. And I don't know what kind of compression they used, and I wasn't up for doing a lot of crypto that day. I want to be like a fun project. So I did some small change to my plan, and trying to explain to my wife during the night what I'm doing. She tell me like, close your laptop and go to sleep. I'm like, no, I need to find that. So I changed my plan, and I said, well, I know I'm not working on the right version right now. I'm gonna wait with that for later. I'm gonna work on the 2.10 version, the one that I managed to extract, and maybe I'm gonna find a vulnerability that will actually work on other versions as well. I'm gonna find maybe a generic vulnerability, and then I'm gonna exploit it, and maybe I'm gonna do something with it. So I started looking at the firmware, and then I found the first vulnerability in the 2.10 3.10. It didn't took long, and from what you can see here, all the files that you can browse to that the HTTP server revealed to the user are under web CGI bin. Now, inside of it, there's the index.html file, and there are two directories. And it's configured, the web server is configured that it can only run CGI files from CGI bin manga. You can see that directory over there, the lower one. And all the CGI files are actually inside this directory. But there is another directory called hasync, and inside of it you can see it here. This is the what there is inside the directory. There's another file called hasync CGI, and it's just a symbolic link to manga CGI box.cgi. Now that's interesting because there is CGI outside the CGI directory, the manga directory, and the web server isn't configured to execute the CGI file from there. But you can actually surf to this location. So what happens if you're trying to surf this location? It lets you download it. And that's pretty cool. So I went to my target IP address, put the IP address, CGI, bin, hasync CGI, and it just gave me an opportunity to download this file. So I downloaded it, and I got an x86 file, binary, called CGI box CGI. And that's the holy grail of the binaries inside that firmware, because as you can see, this is the firmware that I managed to unpack. All of the CGI files are just symlinks to the CGI box CGI. This is the binary I really want to research. This is the binary I want to find a vulnerability in. So if I manage to download it, I don't even need to open the firmware. I just got it. So that's really good. I started looking at it, I ran some strings, found out that it was compiled with something called libcgi, and now I have some sources. So it wasn't just an opaque binary I could actually start working with. And sources, like, it's always better. I don't know why I put this picture, but if somebody tried to reverse or does it for a living, then you know it's kind of hard. And if you have sources or symbols, it usually really helps you. And if you have sources, then reversing without sources looks something like this. And if you have sources, then it looks something more like this. And now it's like the fourth version of my plan. I have to revise it again. Now I have the CGI box. So now I'm working on the exact same binary that my target has, because I got it from my target. And and now it's actually time to start reversing it. It's time to start working on the real problem. And I tried looking at the attack surface because I didn't have credentials. Like I told you before, I tried everything. I wasn't able to log in. And I tried looking what I can do if I didn't have credentials. And I found this CGI called API IC2.cgi. I think it's supposed to be for remote login for sysadmins, I guess. I didn't actually look what it does because I wasn't able to bypass the login screen. I looked at the login, and it was pretty solid. They checked for everything. They checked for the right credentials. They checked for buffer overflows, all the common stuff. But when you look at the logout, they didn't do such a good job at the logout. They focused all their energy on the login screen. And if you look in the logout, that's the actual code for the logout. There are two vulnerabilities here. So you can see it's trying to construct an SQL query out of data that you send to it over one of the cookies that you used for that sends to you when you manage to log in properly. And so first of all, we have an SQL injection here, and that's pretty cool. But I want something better. I want to execute an actual code on that machine. And I found out a couple lines after that that when it's trying to construct the query, it just copies everything from the cookie that you send to it into a place called str final query, which is just some place in memory, on static memory. And you basically have a buffer overflow, pretty classic one. If you send it n bytes over the cookie data, if the valid cookie is 1,000 bytes, it will copy 1,000 bytes into memory. If it will be more than that, it will copy as much as you send to it. Good for me, sucks for them. The place it copies data to is this place, the str final query. You can see it here. I started thinking, well, how can I exploit it? Because you can start writing on a lot of pointers. I tried doing some stuff, and if you go to str final query plus 14 E47 hacks, then you have the global offset table. And I thought, well, maybe if I'll be able to write enough data from str final query, then maybe I could just run over some of the pointers that you have here, and whenever one of those functions gets called, then it will jump to my code, and you can get code execution this way. Now, 14E47, it's pretty far. It's a lot of data to send over the network. And an exploit would look something like this. This is the HTTP request that you need to send. And here you see the cookie is called beauth. And if you want to send, you have to send a lot of data. See, you can look at the content length. It's supposed to be pretty big. And I really want to try it on my computer before I try it. I didn't want to send this to my city's load balancer because I didn't want to crash the network for all the tourists using Tinder and Facebook. So I said, well, I need to build something on my computer, like a working model to check it before. But for that, I need to unpack the firmware. I need to unpack the 380 firmware to build this test environment. So a bit like a small recap, we have the boot data to bin, which according to the main DFL, it's the int_d. All the important files should be there. And according to the entropy, it's either compressed or encrypted. And I have to figure out how to decompress it or how to decrypt it. Now, I know it's the int_d, and I didn't know a lot about int_d, but I believe that if you don't know something in Linux, you have sources, and the best place to look is the kernel sources. So I start with the main function that's trying to identify the int_d image. And it's a pretty simple code. What it basically does, it just reads the first block in that file and trying to find what's the best method to decompress it. And this is the code from the kernel code. This is the kernel code. And if you look in the same kernel, the boot data 1 that the company Peplink sends with their device, then you can see here in two places they have XOR instructions. And that's the same function from here. And you don't see any XOR instructions here. So maybe it's something that they added, that the company added. And yeah, they tried to implement some kind of encryption mechanism using some XOR encryption. And I just copied the code from there. I wrote this, you can find on my GitHub, inline assembly in Python for x86. So I just ran it, and it didn't take long. And I have a decrypted firmware on my computer that's working. That's an IP address inside my home network. And that's pretty cool. That's worked. I was pretty surprised it worked pretty fast. And I tried my exploit, and it didn't work. HTTP headers can be only up to 64K on this specific web server, and you can't send packets so big to exploit it. So that sucks. That's it. Anyway, so I started poking around, and I found a different file called firmware CGI, which isn't a symbolic link to the CGI box. It's a static file, stands on its own, and also compiled with libcgi. And here, str find query is only 184 hex bytes away from the global offset table. And that's really good for me. And an exploit will look something like this. Like, this is the str find query. Here you have some stuff. Here's the GOT. And all I have to do is just run over my shellcode, put an address, and jump back to it. It's kind of like an embedded device, so you don't have any protection mechanism, no ASLR. They didn't implement anything. So it's pretty easy, pretty fun. And that's what I thought of it. Now, I wanted to do a demo and check it, but then somebody came to me from Checkpoint, told me, no, Checkpoint's a company in Israel, told me, you know, I learned law before I joined this company, and you shouldn't tell anybody if you did something. So that's what I can say about that. I posted the vulnerability on my blog and sent some emails to the company. They actually responded pretty fast and patched it in all of their devices. And a couple of days later, somebody that I call him the Ukrainian hacker sent me this email and started asking all kind of weird questions about how I managed to do this, what should I do with the vulnerability after I execute code, and he was pretty interested in exploiting it, I think. Every single of his emails was in a more broken English, so I couldn't actually understand what he wanted from me. And I think that same time Russia invaded the Ukraine, so I didn't really want to help him, didn't want to be in the middle of a cyber war. So I just told him, well, this is the way to unpack it, and just leave me alone. The company were pretty nice. They sent me a little bouncer, a small one for home. So this is my home router right now. Yeah, my wife calls it the noise machine. And it's an excellent body Christ folder, actually. That's it.